Hi, my name is Shadi Atia, professor at Liège University in Belgium, and today I'm going to talk about the experiment setting. Well, today's presentation is a third presentation in a playlist on experimental research. I advise you strongly to watch previous two presentations on experimental research. Well, this presentation is for labs managers, scientists, including PhD students, postdocs, and professors who are concerned with how to manage and control the experimental field or the field of experiments or the experiment labs. And the secondary targeted viewership of this presentation is people involved in the risk assessment and in the laboratory design, laboratory managers, biosafety officers, architects, designers, construction engineers, and builders. Well, we are having today's presentation as part of the experimental research series. And as we mentioned before, that there is two families of research: the quantitative research involving the modeling, the observational, and the experimental research. And the second family is quantitative research. And in this sense, we focus on experimental research in this series. And for sure, this involves mixed approaches that can combine methods from the quantitative or from the qualitative approach. But when we talk about experimental research, we mean here mainly manipulative research. So it is the study design that alters variables or one variable for comparison against a control conditions or baseline. And in this sense, we are not talking about observational research, because in this sense, the observational research is non-manipulative, or it is the study design that typically represents realistic conditions. So here we are more in the experimental side. So it's very important to keep this into account. What is the objective of today's presentation? Is to get familiar with your lab setting to perform your experiment in an effective way and to organize the experiment workflow safely and to operate and ensure greater sustainability of your lab or of your infrastructure or your facility, regardless if it's an open field, experimental field, or if it's a contained building or facility. What will be the content of today's presentation? I will talk about the experimental subjects, the experimental setting, the control group importance, and the consequences of the control aspect on the space, because it has spatial requirement, the control of extraneous variables, how to design a lab, and how to assure the quality of a lab and running a lab, and finally some takeaway messages. So let's start with the introduction. What is the experimental setting? What is the definition of experimental setting? Well, simply it's a facility dedicated to the placement of the equipment and systems required to perform laboratory procedures. Safety and security must be considered when selecting the facility design and its features. And laboratory types include research labs, academic facilities, forensic and crime labs, healthcare buildings, government facilities, industry labs, and more. So it's important to keep this into account. Well, when I talk about setting, I'm focusing in this presentation on two types of settings: laboratory experiments conducted in well-controlled environment that are easier to replicate, that allow for precise control of the independent variables, and low external validity studies. And I'm looking about field experiment where you can manipulate the independent variable, but in real life setting, more likely to reflect real life with less control over the independent variables. If you want to know more about the quasi-experimental or natural experimental, you have to follow the playlist on observational research. Now, when I talk about experimental research, I'm mainly focused on controlled experiments. So in this sense, I'm talking about the elimination or the control of variables. I'm talking about having a controlled setting or environment, and therefore we call it experimental control. When we talk about experimental conditions and when we talk about experiments that are controlled, we are talking here about lab settings, physical testings, field experiments. Those what I mean by controlled experiments. I'm not talking about non-controlled experiments where we have more natural experiment or living labs. This will be in the following videos in the observational research, but this is an example here. If you like the tests that were conducted, like nuclear explosion by Russia in 1945, 1953, and 1966 in Kazakhstan to investigate the effect of wind direction on the nuclear effect in relation to wind. So this is an example for a non-controlled experiment. I'm not going to talk about this type of experiment in this presentation. I'm mainly talking about controlled experiment. Let's start with the first item in today's presentation: subjects. What are my experiment subjects? Well, it depends. Subjects is a very broad term. It can be human, animals, plants, viruses, materials, structures, machines, devices, dummies, and so on. So depending on my subjects that I will test or I will measure or I will have conduct my treatment or process in general, my lab setting will be designed depending on the subject. And the subject scale is makes a difference. It can be a human being, it can be a small sample. So the subject is very important to determine, because the consequences of the determining of the subject will allow you to design your lab and spatially succeed in running it. Now, as I mentioned, your subject can be a dummy in a car, so this means that you need to have a big space because we run a lot of cars doing crash tests and you are always testing your dummy. This can be a subject. Another subject can be just blood samples, so in this sense you don't need a huge space, you will have a smaller space compared to the car crash testing facility. Your subject can be also an object. It can be a chair, it can be prototypes if you are working in the industrial design field. So the subject is the basic that will allow me to define the spatial requirement for my lab setting. This is number one. Let's talk now about the lab setting that comes as a following step. Well, the setting is where the experiment is carried out, and many experiments are carried out in the laboratory where control can be exerted on the control variables, thereby eliminating them. And as you can see, we can have a small test cell, we can have a full-scale test facility with human beings, but there are different types of labs, including the energy-saving environmental labs for engineering domains, clinical labs, environmental labs, food and beverage labs, forensic labs, life science labs, material and science labs, pharma labs, and psychology and social sciences labs. And let's have a look on different spatial arrangement of these labs. As you can see, this is obviously a clinical lab. You can have a certain layout, a certain architecture, interior design makes a certain condition. Another very interesting example, this is a wind tunnel where we are testing the aerodynamics for bicycle cyclers, for example, and you see the aerodynamics and the flow. This is another type of lab. This is looking more like a psychology lab where you have a lot of tests and people will come and fill up surveys, for example. So this is another lab setting. Another lab setting can be more this observation, more psychology, social sciences. You are observing, you are conducting an experiment, interviews. This is another type of labs. This looks like a climatic chamber or something like, with a fan and a vent, and most probably you are conducting some test on comfort or thermal comfort, air quality. This is obviously a material science lab. You have different materials and there's testing. This is back to clinical, very clean, tidy, or pharma. A pharma lab also can be possible. Chemical lab maybe. And this is another type of lab which is an open field. And this is part also of experimental research, controlled experiment research. It can be open field with different cells, with different plants, testing and so on. This is another example for an acoustic lab, which is you can conduct different tests and resonance and so on, and test products, materials, and so on. And what is also very new and not common is to have virtual lab. And this we can see it, for example, in electrical engineering, for example. They use virtual labs. So they don't have a physical setting, it's just a virtual lab, it's a software, and then you conduct your tests virtually by testing your capacitors and so on. So this is all types of lab you need to be aware about, and you have to make sure what is the setting that I will need in order to design my lab and start running my experiment. Now, before continuing, I need to explain here the control group concept and the consequences of the control group on the space. The purpose here is not to talk about control groups or the concept of pre-testing, post-testing, or the concept of controlling or reducing the noise of your experiment, but I'm more interested in the consequence of having a control group on your spatial organization of your lab. Well, what is my control group, or what is my baseline? In experimental research, a control group is used as a baseline measure, and the control group is identical to all other items or subject that you are examining, with the exception that it does not receive the treatment or the experimental manipulation that the treatment group receives. So let's have an example. I have my baseline is potato in water, plain condition, and then I have potato in water with sugar and potato in water with salt. I need to have the 3 experiments running in the same time so that I am able to measure the effect of my treatment or the introduction of sugar or the influence of sugar or salt on the potato in the same time. This means that I need 3 jars. Spatially, that cost me nothing because I am just, my sample or my subject actually is a jar with water. But if my sample is a chamber or a big space, then spatially that will cost me a lot. So therefore, when we talk about Y control groups, we say that they are very important for benchmarking to measure the success or failure of the test. They allow to minimize the impact of the dependent variables, and they highlight false positive, signaling whether an update is more effective than the original, and they remove the confirmation bias that we want to avoid to have a high confidence level in the findings or the tendency to force the hypothesis into results. And therefore, the consequences of having a control group is that I might end up having a chamber, 2 chambers to test the same phenomena in the same time. As you can see, this is another climate chamber, a climate chamber with 2 compartments, so that if I have to do a comparative, this comparative approach, I need to measure, for example, my baseline or the control group sample with the treatment group sample. So this is important, or my treatment sample simply. This is another consequences. You can see spatially if you are doing, let's say, underwater pressure or what kind of installations that doing submarines or certain simulators, you want to get some people in one simulator and another simulator, and you will have your baseline or your control group sample in one simulator, then you have on the other simulator the treatment group. So spatially this has a huge consequence, and you have to foresee that before when you design your lab. Same goes when you do testing with human beings. If you have observational room, if you have the testing room, if you want to have 2 groups. Unfortunately here it doesn't show that you have 2 spaces, but then you need to have a control group and you need to have a treatment group. And sometimes this is complex, and sometimes some experiments need to be run in parallel, so they cannot be run in series. So this has a spatial consequences. Here you can find here different, this is different coating for a big field, and you can see the different comparative. You can have your baseline, let's say, coat, and then your improved coat, and then you start later on to do testing, because then you will have most probably the same condition and the same solar exposure, the same rain issues and sky condition and so on. So this is important. And as you can see, this is another example for test cells where the comparative approach or the control approach is very clear. It's not a surprise. Here we can have a window with a test cell for the baseline without shading, and then we have alternative 1, alternative 2, alternative 3. So here I can have my treatment group or my treatment sample or my treatment subjects, and here I have my baseline subject or my control subject. So without thinking about the control group when I'm designing my lab, it will be very difficult if this has a spatial consequence. So it's very important to take into account. As you can see, again, we're talking about here test cells that are used in experimental research very commonly. We have a baseline test cell and we have a treatment test cell. Maybe this one has air conditioners and this is without air conditioners, and then I can start to measure the impact. And therefore, when I say that the space or the spatial consequence of your sample has an impact, if your sample or your subject is blood samples, then you do not have a big spatial requirement. But if you have a lot of blood samples, then it will be huge. It depends. And the same goes here. If your simulator is a small simulator and you want to test the impact of, you want to test a certain software, you will need to have several simulators. Technically, you will have a huge demand for space. So it's very important to take this into account. And we should not forget also that many researchers today, they integrate their research labs in their homes. So even if you are going to create a new lab and it's in a small facility in a garage or in your home or backyard or whatever, you need always to know what will be my control group, how I will establish this comparative approach in measurement, and what will be the spatial consequences, and how can I prepare and plan and design my space beforehand. Still, I want to talk about the control, because it's very important, and actually this is the advantage of experimental research, that I have a lab facility or I have a field where I can control the extraneous variables. Extraneous variables are very important to control, and we're talking here about physical control, design control, and randomization and statistical control. Those are the 4 controls that we can apply when we talk about reducing the noise for experiments. So what we do actually, how to control, physical control simply is holding constant the value or the level of control variables throughout the course of an experiment. In this case, for example, it can be the temperature. I will fix the temperature in all my experiments, and I make sure that in the all climate chambers on my all my lab testing facilities, I will have the same temperature. When we talk about physical control, we talk about subjects relevant to, for example, if it's a human specimen, it can be age in general, intelligence, motivation, aptitude, and maybe the level of contamination. If we are talking about situation relevant, then we're talking, for example, temperature, noise, light, operation, nature of the task. And if we are talking about the sequence relevance, we are talking about a practice effect, a fatigue effect, or adaptation. These are all examples of different control strategies for different situations, whether they are the subject relevant or situation relevant or sequence relevant. Now, design control is simply the use of experimental design to extraneous causal factors, and it's aimed to standardize participant, avoid experimental effect, and avoid bias, for sure the bias. In this sense, randomization and blindness is very important, and here we try to have the random assignment of subjects to treatment conditions to ensure equal representation of the subject characteristic. So maybe this randomization requires that I have different facilities. Sometimes it requires, so therefore spatially it's important to take into account. And also we can exercise a kind of statistical control by adjusting for effects of extraneous variables, by adjusting the value or the dependent variable for each treatment condition. So this is very important to take into account before designing your lab and setting the space and making sure that your setting will allow always to produce baseline or a control group result and a treatment group result. Now let's talk about lab design, and this is more interesting maybe for designers and lab managers. When we talk about lab design, first of all we need to establish requirements. So what are the requirements of the experiment in order to design a lab? So successful laboratory work depends on many factors, including the design, skilled scientists, calibrated equipment, and consistent environment. These are the main components of any lab. For sure, on the long term, when we put the temporality or we put time to it, we need that the lab is running and operating in a sustainable way. We need to make sure that safety and security is respected, and therefore we need to have all risk assessment done, and we need to have up-to-date equipment. So this type of principles or features, they are part of any lab. Now, when we talk about labs, we must talk about risk assessment and the needs to assess them. So normally experimental laboratory must be designed, constructed, operated, and maintained to fulfill their intended role and keep laboratory personnel and the environment and the wider community safe from the risk associated with handling biological agents, for example, or chemical agents or any hazardous agents. So in this sense, we need to do a simple risk assessment, and we need to make sure that when we will design our lab, we will have different risk assessment levels, and we'll have mitigation measures for each of the risk level, and we must invest in training, not only in the physical setting and in the physical design and the choice of material and the finishing and all the safety requirements regarding fire and exhaust and air and so on, and positive pressure and so on, but also we have to focus on how to train the people to handle a difficult situation. Another important factor here, this brings us to the health and safety. So to drive superior lab safety performance, leaders need to align their words, action, decision, and personal behaviors with the lab safety priorities. You must have very strict protocols, standards, safety must come first. You must have a safety responsible, and you must make sure that the safety protocols are respected. You have to determine the right priority for your lab safety, training the staff for the lab safety, creating the habits required for lab safety, measuring it and doing audits, inspecting for lab safety, and prioritizing lab safety all the time. This is all very important so that you have actively practicing lab safety for your lab. This is a very important element part of your lab design and how you run your lab. Now, let's have an example. I mean, a lab can be huge, can be small, depending, but you must think about a lot of design consideration associated with your design of your lab. First of all, you have to think about your user requirements, and specification, the location of your lab and the floor space, the movement of personnel, the specimen or the subjects in this case, materials, waste, emergency exit, the furniture of your lab equipment, the maintenance, the cleaning, the decontamination process, how you will handle the waste, the HVAC systems, if you have fume hoods in chemical labs, for example, if you have HEPA filters, which are very stringent, they assure that you will not have transmission of viruses or bacteria, compartmentalization, or simply zoning, in order to make sure that you are controlling the pressurization, because some labs or some parts of the lab facility they require to have positive pressure, other lab areas need to have negative pressure to make sure that they will have no mixing of substances in the air, especially if you are in a pharma lab. They're very sensitive to transmission through air. If you have a biological lab, medical lab, anything that has to do with viruses, bacteria. So all these aspects are important, and also you need to look at the safety equipment that you have, such as the isolation switches, the fire extinguisher, the safety showers, the waste disposal policy, and the storage, and for sure the cost of all that. And simply here there's a very interesting guideline. It's called the Laboratory Design and Maintenance. It's developed by the World Health Organization. I invite you to download it. It's an open access document, and it gives you some requirements and recommendations regarding the core requirement for a laboratory. And here they are giving different examples, talking about the lab equipment, the features of the laboratory equipment in the core. Here is if you have a heightened control measure, and here is you have very high control measure, and every time they are talking about the different aspects related to the specimen storage, how you do it, the workbench, the centrifuge, if you have a heat block, the sink and the drainer, the biological safety cabinet, the processed specimen storage, the waste management, the storage of consumables, and the hand wash basin. These are all considerations when you are designing a lab and running the lab, and they need to be taken into account. Let's move now to quality assurance. How can I assure the quality when I am conducting my experiment in the lab? Well, first of all, you must have a lab charter. This is a best practice, so you have to define and publish a lab charter for your lab. And the purpose of a charter is to clearly and concisely explain what the lab should do and how. So the charter could be as short as: the SBD lab, for example, delivers innovation to radically improve occupant well-being and improved comfort operation. The lab lives in an open ecosystem of idea generating solutions, decision support tools, and prototypes. For example, this is a simple lab charter that you can have, and in the charter you include the mission and of your lab, and it can have a link to the charter. You need to define the lab's governance model and the process, location, budget, and you have to have a kind of debriefing process, orientation days or orientation training for people who start to get in the lab. And you must publish this charter, make it known, and be proud of it as part of your protocols. Also prepare your procedure manuals. The lab, in any lab, you must have a certain series of equipment and tools, and you must facilitate accessing them and using them, whether by visual or video guides or simply having manuals. So the lab is the pipeline for your experiment and publication. Prepare procedures manually for experiments, so try to make this more automated or semi-automated, so that if you have an intern, if you have a new researcher or a scientist coming in the lab, they have to know about the equipment, learn about it very fast, and easily go through the learning curve in a smooth way, in an open access way. So document how tests are performed, train the new professionals, remind personnel to how perform tests, create a troubleshooting test problem log. Any issue that happens with certain equipment, you must have a log so that you can trace, and then you can revisit later your maintenance contracts, or if you have a calibration and maintenance contract, and prepare the lab for Q&A plan in case you have different scenarios, what can happen. So this is all important. And here, for example, I give you an example, the Institutional Animal Care and Use Committee, they have very specific guidelines and protocols how to equip and prepare a lab if you are using animals, how to store the animals, how to treat the animals, how to prepare, and so on and so on. So this is an example for a very useful document. Also, you need to keep into account when you are running a lab or designing a lab record keeping requirement. Today you must have specimen collection and labeling procedures. Try to your best. There's a lot of equipment that can generate specimen tracking numbers. You must have such equipment on spot so that you can trace and track and document your samples or your subject responses, whatever they are. Quality assurance also includes that products and material quality control that you will use in your experiments. So if you are in a material lab, you must make sure that there's a certain expiry date and so on. Also in the pharma, documentation, the testing and the commissioning of the lab equipment in general, accreditation and certification, if the lab can get an ISO certification or accreditation from a certain third party to make sure that you are, for example, respecting safety or having quality assurance and so on. Operating and maintenance manuals, maintenance records and inspection. Consider the equipment heat gains, very important, because today in many buildings we have too much heat and then we have a climate that is changing, so it's getting hotter and hotter, and in many labs there's fires and there is high heating loads, demand for cooling. Later on we have ad hoc solutions to integrate cooling or introduce a ventilation system. So you must make sure beforehand when you're designing the lab what kind of equipment you have and what kind of heat they will generate, what kind of noise they will generate, and in advance prepare the lab for that. Also, one of the good practices is to have a lab insurance policy. So every lab requires an insurance policy to protect the user lab infrastructure and equipment in the event of an accident, and start with risk assessments, and based on the risk assessments they will tell you if the risk is high or medium or low. Based on that you can invest in an insurance policy or not. Third-party damage or inquiries are also important here. Damage to environment and neighborhood caused by uncontrolled discharge of hazardous toxic vapors or chemicals, very important. I lived in many cities with university cities or campuses with intensive polluting labs, and in the night you can feel that something is going wrong, or sometimes there is gas leakage in the building. So these kind of considerations are important. So seriously, if you are looking for peace of mind, then invest in a small amount of the premium against the covered risk is very strongly advised, because most probably insurance companies will not insure your lab before that you already applied safety measures and that you conducted a thorough risk assessment. So this is the end of today's presentation. Some takeaway messages regarding the lab setting, if you are using it or if you are designing it or if you are running it. Well, successful laboratory work depends on proper design, sizing of equipment and sufficient workspace. Adequate storage space for all material, including devices and materials, is in common use that are considered hazardous. A budget for regular maintenance of facilities and equipment, as well as annual cost for new and replacement equipment, supplies and proper waste management. Laboratory occupancy load limits set at a safe level based on building and fire safety codes. Make sure that occupants, the number of people who occupy the lab is corresponding to the lab design assumptions. The size and the design of the laboratory teaching facility, if you're using it for teaching a facility, it must be from the beginning thought that you will have students coming in. Chemical and physical and biological hazards and the needs of researcher must be taken into account. So these are all aspects that are very important. Don't forget that today with the remote working and the remote experiment, we have now more and more we are recruiting patients also for research studies that do not need to come home. So also if you can have a laboratory sample collection process where you don't invite the subject to the space and you just focus on the treatment of the subject, this will be a very good idea, because then you can rely on post or any other way of delivery of your samples, and then you just have a space for treatment. This will reduce the space you need for a lab and for sure will reduce all the load associated with maintenance, risk assessment, health and so on. So this is also something to think about, is to outsource the data collection and not do it on the lab if possible. Not every field of research can do it. And for sure, don't forget about virtual experiments. Today it's not a tendency, but you find it in some fields, like I mentioned before, electrical engineering. They do virtual experiments, so no more than ever before virtual labs are getting used in experimental scenarios, and this is also something that will be coming more frequent in the future. You have more and more virtual labs. Now the closing remark with best practices: define and publish your lab charter conduct yearly evaluation of the laboratory investigations to determine their effectiveness, provide periodic training in lab logistics, including setup, safety, management of materials and equipment, assessment of student practices, especially when you introduce undergrads or grads to your lab, standardize the process data is collected by scientists using tools, materials, data collection techniques, models, and even training materials, so that you have an automated approach and you do not every time start investing in explaining how to use the lab equipment. And finally, enable researchers to develop safe and conscious lab habits and procedures. And don't forget what we mentioned before about the spatial requirement of a lab and the control aspect. Those are all important best practice to make sure that your lab is successfully running and really helping you to conduct the research that you want to do. Finally, I want to remind you that this presentation was part of a playlist on experimental research. I really would like to ask you to subscribe to the channel to watch future videos. There will be a series of following videos related to the same theme of experimental research. Please like, subscribe, comment on the video if you find anything missing, if you have suggestions. Don't hesitate to interact, because this is very motivational for me, and it gives me a sign that I have to continue. And at the same time, it's a kind of beneficial for others to start to see if the presentation is useful or not. So I thank you very much for your attention. Today's presentation was about your experiment setting and your awareness about it. I hope that you will settle soon in your lab and you conduct your research experiment as soon as possible. Thank you very much for your attention.